Where's, she's here. Okay, Heather just came back. Okay, we're good. Neil's here. Okay, James is here. Both the Roberts are here. And looks like Peter's here.
Yeah, I'm here.
How's it going, man?
It's very early in the morning here. It's 4 o'clock.
Whoa, okay. Sorry to get you up so early. Thanks very much for joining us. It's really a treat to have you.
Thank you.
Yes, fantastic. I've been watching more of your works. Like I said, I was watching your Wallace line thing there. But before we get into everything, how's everything going?
In Australia, well, I'm up here staying at my son's place in a place called Noosa, which is right on the beach in North Australia, Queensland. So it's really nice at the moment. The weather's a bit cold over there, I guess.
Welcome to the December 9th edition of The Electric View. I'm Neil Thompson. Today we have a very special guest, Peter Mungo Jupp, with our friends Neil, James, Robert, Heather, Buddy, Eugene, Dave, and Dave. We are discussing his inspirational work on electrical fossilization and geology, our planet's uncertain past, and debating the mechanisms which shaped it. Please take a moment to like and subscribe. Oh yes, definitely here. Negative 14 to negative 20 for me.
Joking.
Wow.
Ooh. Well, it depends on whether or not the sun's up.
That's Celsius, right?
Yes, of course. Still cold.
Yeah, I know it's cold, but
but yeah, nothing
for the
too bad.
Where does everyone come from? Where are you, Neil? Are you in? I gather you're on the eastern states, or what?
I'm on the eastern coast of Canada.
Oh, you're in Canada,
yeah.
Right? That's Prince Edward Island and all that.
Yeah, I'm right. I'm only about an hour from Prince Edward Island to the Confederation Bridge.
Okay.
Not even.
My son was married over there. That's interesting.
I believe we talked about this one time when we were in the middle of wandering around. You were like, "Oh, right, it was my son's got married up there or something." Yeah, I'm from that little Moncton area there.
That's a beautiful part of the world.
Oh, lovely, lovely. You definitely got the full seasons. I'll tell you that. I've experienced, hitting positive 35 is not impossible, and hitting negative 35 is not impossible.
Don't go to Canada in the winter.
Well, just here. Maybe not just here. But
yeah, like Calgary's like buried in snow.
Well, occasionally it comes and goes. Like sometimes it's like positively tropical at +7. When in the middle of winter, but in the middle of January, she can get really chilly. But anyway, So we'll go around the table here. You know me. I'm obviously Neil Thompson.
Yes, I know your outrageous reputation.
Outrageous, yes. Well, I guess I have we'll see how that goes. And we'll wait until you're done the interview before you compliment me. Anyway, Neil Creamer's there on the end. I'll let you just go down the list there. So it's Neil, then James, and so on. So go ahead, Neil. Just do your thing.
Yeah, we can do just quick introduction.
Hi, Peter. I'm Neil Creamer. I'm in Northern Ireland.
Oh, really?
Yeah.
Well, it's all happening there at the moment with UKIP and exiting the EU, isn't it?
Oh God, don't tell me.
Reading about it just before.
Yeah, it's very exciting. It's great to meet you, Peter.
Oh, great. Good to hear you. So you're near Belfast, are you? Or?
That's right, very close. 20 minutes from Belfast, just up the motorway.
Right. Oh, a long time since I've been there, but that's a pretty part of the world as well.
Very nice, and not as cold as Canada, not as warm as Australia.
That's the perfect place.
The perfect place.
Ambient.
Yes, the Call of Cuchulainn is playing or whatever. Yeah. I actually, when I got married to that song, believe it or not. I'm not. Hope it doesn't mean anything bad. I just like the way it sounded.
Sure, it doesn't.
James, you're next there. James, this is James Sorensen. I recognized his voice immediately when I heard it. I was like, hey.
This is James, and I'm up in the Colorado Rockies in a mountain cabin at 0 degrees centigrade here right now.
Wow.
And I've been working mainly with Ito on the simulation program for his structural model.
Oh, yeah, great.
Recently, I've been working also with Don Scott. I have a really cool simulation now, 3D interactive simulation of the Brooklyn Current.
Oh, that sounds fantastic. Oh, Don?
What was that?
The Don, yes. No, well.
Don Scott, yeah.
Yeah, great EU advocate.
Yeah, I think that figuring out, we all talk about electricity in space, but we haven't really discussed a lot about what the power lines look like and who builds them.
Yes, actually, that's a big point of contention.
That's an interesting one, isn't it?
So I'll just grab the screen here for a quick second and show you this little simulation. I think you'll all find it interesting.
Yeah, why not? Well,
do you see it now?
I'm not getting any visuals here. I don't know what's wrong quite, but I'll just have to imagine it.
Yeah, let me try sharing again. Maybe you'll get
part
it.
of the where is that on the website? I was just on there the other day. I didn't see that at all.
It isn't actually. It's on the website, but you have to know the address and type it in. It's just I need to I want to create some pages and do a long discussion about the Berkmans before I put it out there.
Yeah, there you go.
Okay, that'll be fine. I'll have a look. You can always have another one if I can get up at 4 o'clock in the morning again.
We'll
That's
try
what
to
I'm
make it
saying,
next
man.
time. We'll try to make it more comfortable. For you.
Yeah, especially since we got you up so early. Let's not take away.
Yeah, and let's go down the line then. So next is Robert. So we'll go with you.
Yes. My father's on the show too, so we'll just go. I'll include him with us. We're in Salt Lake City, we're basically Utah, and
hang on, Robert who?
Robert Hawthorne.
Oh,
I'm on the. We've had a few conversations on the EU Geology site, and we also met at the Electric Universe 2017 conference, and I'm a big fan.
Rob Hawthorne, yeah, sure.
Yeah. And our work basically consists of the rocks at Upheaval Dome, and we worked with Gene Shoemaker, and wanted to share a little bit with you because I know you focus a lot on him, on his findings.
I did initially. That's one of the things that always intrigued me, that collision between Comet and Jupiter.
Yeah, I'd like to share with you what we spoke with him when we were at Upheaval Dome and everything. Yeah, so I'll just move on to the next people and get these introductions out of the way.
Okay, sure.
Sure. Heather, let's go with you. I'm skipping over
Hi.
Robert, unless Robert, you senior, you want to speak too. Say hi if you want, but off to Heather.
To Heather.
Yeah.
Hi, I'm Heather. I'm in Detroit, Michigan, and it's 33 degrees here.
We're all doing our weather.
Good number.
Yeah,
been to
right.
Chicago, never Detroit.
Sorry?
I've been to Chicago, but never Detroit. So it's not far from Chicago, is it, Detroit?
No, it's not at all. But we actually have better weather because of the lake effect.
Oh,
So,
right.
yeah, you might have experienced, they'll get all the big heavy snow before it comes to us, and it'll just dump on them, and then we kind of get the leftovers. You know what I mean? We're protected by the lakes. So it's if you ever have a chance to visit Michigan, I recommend it to anybody in the world because of the lakes.
Yeah, well, the lakes are very pretty, aren't they?
Oh, yes.
You got to see Lake Michigan.
Well, that's off Chicago, is it, Lake Michigan?
Yep.
Yeah, that's what I saw. I went there in wintertime, though. Pretty cold.
Oh, yeah.
The Windy City in wintertime.
Yeah, that's the worst time to see Lake Michigan, is on on that side of it in the winter. But if you get a chance to come back in the summer to either side, it's beautiful, and it lends itself well to a lot of the stuff that you're specialize in. So I think it's worth a look for you.
Right, I'll keep that in mind.
But it's not windy. It should be windy city, shouldn't it?
Right.
Windy.
No, I mean literally. Yeah, it's windy, not windy.
I don't even know why it is so windy. I assume it just comes off the water. But
yeah.
Either way.
No. I mean the name is it should be read like windy.
I got that right.
Oh, don't ever attempt. I mean, the English language is basically something that goes into the alley with other languages and beats them up, and then searches through the pockets looking for loose vowels. I mean, it's a nasty language. Nothing makes sense in it. The same word can be pronounced 5 different ways. Anyway.
Well, it's totally flexible. That's
it's true. Well, I'm just going to go down the list, though. Dave. I know you're there. Dave Brown.
Hi.
Brown.
Howdy do?
You snuck on. I saw.
Hey, can you guys hear me?
Yeah, we're doing introductions. Introduce yourself. Apparently talk about the weather of where you're at and where you're at.
My name's David Brown, and I'm from Dallas, Texas. Yeehaw! And it's about 38 degrees, but it's sunny and beautiful. It was gross yesterday.
Wow. Nice and cold then, yeah.
Yeah, man. I've been watching you for some time now, and I'm very impressed with all of the fossilization topics that you bring up. I sent you a piece that I found in Texas that I thought was a dinosaur foot. So anyhow, I'm on the same bandwagon there. So I love your work.
Thanks a lot.
And Eugene.
Yeah, hello. My name is Eugene. I'm from Minsk, Belarus. That's in Eastern Europe. And right now I think we have like literally exactly freezing temperature. So that's 32 Fahrenheit, I guess.
Right out the zero.
Or 0 Celsius, if you like. So I'm a theoretical physicist by training, and I work as a researcher in physics right now, doing my PhD thesis. And I'm interested in EU ideas for several years now, and I've participated in several conferences, both by the Thunderbolts and Ben Davidson's. And I'm on this podcast because I love you guys.
We're very open here to talking about new ideas, and we're not too hard on each other. It's a lot easier to be flexible when you have like no scholarly papers riding on it. You know, we come from different varied backgrounds, and we're trying to really get to the essence of a subject and look at it from multiple different philosophical ways. And obviously, there is a big thread of the electric universe, plasma cosmology that runs through it. And I'm very happy to have you on because one of the things that I have trouble. I'm not an expert by no means, but we don't get a chance to talk about catastrophism nearly enough. And I definitely want to talk about that with you. But we have one more person, and that's Dave, the guy that's running the show right here. Well, doing the thing.
Oh, I think Robert's running it right now, but that's okay.
Okay,
I'm just catching the wind in the sail. That's okay.
But yeah, and then we'll start right up. So
yeah. The call itself is an extension of an initial call that I made into Gene Hafner with the Electric Universe, and it's just extended from there. It kind of blossomed into what we now have as the Electric View, and we're very happy to have Neil hosting it, and it's just a real pleasure to meet you. And thanks very much for joining us today.
Oh, my pleasure.
Notice he didn't tell you what the weather is like in LA.
By the way, I live in West Hollywood, California, and it's 18 Celsius and 64 Fahrenheit.
Right.
As always.
So just lovely.
It is.
Well, it's 29 degrees Celsius here at the moment, so it's quite nice weather.
Nice.
Not even close to Phoenix. I was sitting there dying in these places. When we went on a trip,
it was really hot there, Neil.
We went on our trip and out to Grand Canyon and all these places, and you guys are like, yeah, we can go down here, and I'm just looking at you going, I am out of breath, I am dying, oh my God, I am so out of shape, and it's so hot, I am just melting, and you're just like, oh, it's a little bit chilly. And I'm like, I hate you. You could easily handle it. But we had such a great time, especially seeing those evidence in West Forks and Red Mountain and all those things with Andy Fitz and Andy Hall and those. It was just
that was great.
It was just great. So, let's dive right in then. So,
I can say a couple things here at the end.
We'll say it right now. We'll start a conversation with your thing, but don't make it lame.
The end of the introduction. I'm up in the 6,200 feet up in Duchesne, Utah. We're real close to almost everything that's in the geology section out here. And I had an opportunity to work with Gene Shoemaker in about 2 months before he was killed in Australia. And
those darn Australians.
With Bill Cassidy, who led up the expeditions for meteorites down in Antarctica, won the Barringer Award. The both of them I had arguing on the phone about whether our rocks had any silicate or none. As it turns out, both of those scientists were wrong, and it seems the electric view is probably the one that's correct. But this rock has stumped the scientists for a long time. The last thing was said by NASA that it's actually transmutated elements, which is instant fossilization. And a lot of it has indications of electrical discharge. But I will tell one thing more, and then the temperature here is like about 0 degrees. And one of the things that not too many people know about Dr. Shoemaker is the Shoemaker-Levy 9 comet should properly be named the Shoemaker-Levy 9 comet, because the first person to see it on the blip screen was Carolyn Shoemaker, Dr. Carolyn Shoemaker. Then she called over Eugene, and then she called over David Levy. And so they got the credit for finding it, but it was actually Dr. Carolyn Shoemaker that saw the movement first.
All right.
There you go. So now let's hear from something about...
Awesome. Thank you, Robert. That's awesome.
Pardon me? It's like Crick and Watson too. By the way, there was an unsung female involved in that, from my understanding.
There's always an unsung female.
Not quite that. It was actually her student.
Sometimes you sing, yes. So Peter, let's start with what was your first? And I'm not going to ask you a ton of questions, because usually with just free flow, we usually just have a great conversation. But one of the things that I wanted to start off the roll is, what was your first inclination about your, obviously electric fossilization is your baby, and as far as I know, not too many people talk about it more than you. What was your first, sort of thing that hooked you to it, or made the realization? You know, obviously there's a few hints that get dropped here and there, but something must have you had to stare at something, and it stared back at you to the point where you were like, I honestly cannot believe the old way anymore. And obviously that happens to all of us when you're switching a paradigm. But you're dedicating yourself to this electric fossilization, which, by the way, I'm 100% behind.
That's one of the things. That's certainly just one of the things.
Catastrophism in general, clearly.
Well, I mean, this is where the thread started anyway. Catastrophism. When you were studying all these mammoth carcasses throughout Siberia, Alaska, and they were preserved, if you like, by ice, but there were plenty more that were preserved in other media, such as bogs, peats, and like in South Dakota with Larry Ackenbroad's diggings there. And then, you see some of the things along the Jurassic coast in England where all the ammonites are locked, if you were, in the rock. And it was obvious to me there was things like the mammoths were well preserved and trees and things like that. But I think one of the biggest things that hit me was reading, I'm just trying to remember the title of the book. Who was the author of that? He's just recently died about 5 years ago. Anyway, the point being is it brought out some work that was done in Canada where those trees were changed to silica under some power lines. And
yes,
that's sort of what
I bring that up.
And that was a defining moment. I mean, that sort of led a thing. Then the other thing I think that I thought was really important was the plasmoid studies done around about the 1990s in various labs where they were getting conversion of elements of the electrodes when they were damaged. You know, they're actually transmutating or creating elements that were totally distinct to the solutions they were embedded in. So that sort of woke a lot of people up. You know, I wasn't even a player on that. That was very complex physics, but that brought in the concept of
it's just the concept, isn't it?
Cold fusion, which was actually proved, and so everyone was thinking that nuclear fusions and things like that have to have extremely high temperatures or extremely high pressures and things of this nature, when maybe it was something entirely different. You know, the plasmoids are probably a key to a lot of electric fossilization. Especially the other thing that always fascinates me, and perhaps a third tier here, is the fishes embedded in rocks and various other things embedded in rocks. Now, how can squirming fishes be embedded in rock unless the media that they're in is changed as well? And that's sort of that's a puzzle, but it seems to me it's obvious that the medium itself is also transmutated as well as the organ. So that's the way my thoughts went, you know, and this is all part of these catastrophes that have visited the Earth over eons, or maybe not so many eons, who knows. And so I guess that all coalesced into, and then going to some of these sites like Larry Attenborough's in South Dakota is fascinating. Then the La Brea tar pits, Snowmass, Colorado, and then of course, going up and seeing some of the tree museums in where's the top near Canada on the west coast? That's what's that there? Washington State. There's a fantastic tree museum up there, and this is just heaps of things. You study fossils, ammonites, and you go, how the hell did all that happen? But anyway, that's the roughly as I recall it anyway. But a lot of these things happen in the back of your mind without you even knowing about it.
Well, it is how something like once you are given well, as we say, or we've said here, once you recognize that there is a potential, a distinct possibility that radioactive decay rates are influenced by electricity, and you also know that electric fossilization seems to be something that can happen. And, you know, at least by accident with a power line. But it's something that you're not even trained to recognize things like, I mean, just right up until, you know, until I was going to go right up until probably I was 30 years old, I really didn't understand the electromagnetic nature of plasma. I thought it was just superheated gas. And that's, you know, that kind of idea.
Yeah.
And so you're not... I was just going to say, once you get the tools to see what is possible, you end up with, you know, something that is more homogeneous or harmonious with what your eyes are seeing, with what, you know, like schools of fish, as you have as seen, just look like they're still swimming. And when you get out the X-rays and that can go look through this rock, they're so finely detailed. You can see the internal organs of the animal are fossilized.
Yeah,
so
well,
how the heck does that happen perfectly? Like the thing is still alive. It looks like it's still alive. Like it makes you, it harkens back to like Medusa, like turned to stone, like mythic creature stuff.
One of the fascinating ones that I always found amazing was those crabs embedded in basalt, spherical basalt boulders. And
that was on the screen earlier. I didn't want to interrupt you. It was just an amazing shot. I know what you're saying.
Yeah. I went up there and saw that, and of course, some of the other things. There's two sides. There's the practical types that dig up fossils, and there a lot of theoretical stuff like Rick Firestone is amazing. For instance, he with his knowledge of isotopes and showing that cobalt 60 has different decay rates for the same isotope, opens up your mind. Hello, I thought we've always been taught that isotopes have a constant half-life and things like this. So if they become variable, that opens up lots of things could be happening instantaneously. You get a massive bombardment of different wavelengths of you name it, electricity, ions, whatever. Things open up that you never even thought of. But the real thing here is, in my opinion, that so much work needs to be done in laboratories to actually see how this is happening and take it out of the realms of half-baked theories to something substantial.
That's what I was.
That's where you come in, David.
That's what I was going to ask. Is there anybody who's actually done this in the lab? Electrically fossilized anything?
By the way, Peter, this is Buddy. Just want to let you know, Buddy.
Yeah,
Peter.
hi, Buddy. Yeah. Well, I think the closest that's become to this is this formation of plasma when they whack these electrodes in different solutions and they create new elements in the damaged electrodes. You're getting plasmoids formed as well, and they're the things that are actually changing. So to that degree, they've certainly noticed that there's transmutation, but it seems to have stopped a lot there. Probably don't know about government research laboratories, but it seems to have stopped that work around about 2000. I guess it's ongoing somewhere, but you've got to have fairly sophisticated machinery or apparatus to inaugurate those sort of experiments. And I don't know really needs a bit of funding. The trouble is, I don't know who's going to provide the funding. It's certainly be hard to get in Australia. Everyone's interested in commercial outcomes.
Of course they are.
I'm sure there is people in many ways.
It seems to me that it could be done with very little bit of funding as far as high voltage electricity directly applied to different types of woods and things like that. That might be a good spot to start. Different voltages, different things like that. And that would be just right off of the streamline energy, right out of the system, off the grid.
Well, that's right. In fact, you've probably seen, I think it's in some of my films, Walt Thornhill, when I stay with him, he stays with me occasionally. He did some fantastic work at what they call the Telstra laboratories, which are greatly involved in electrical discharge of power lines and things like that. And certainly he did some amazing work there. But I haven't seen much of it copied in any direction. He was creating fulgurites in the laboratory and discharges of extremely high voltage to spheres and things like that, and noting the results. But that was a bit of a one-off.
Well, there's a significant issue. Just anyone could tell you that it's not necessarily the voltage. We can imitate certain things. We can lower the pressure. We can change certain things. But it is really, if you want to do something that is involving transmutation of elements, then we're in the we need current. And there has been talk. Well, actually, there hasn't just been talk. It is accepted at the moment now that we know that lightning bolts create isotopes. Basically, they create fusion. and that's an off product. So clearly, we're looking at a situation where this merits further research. There is a distinct potential that we might be able to control. And as Edwin has pointed out in the past, there's actually in his model moving from like carbon to a silicate is only a matter of just adding something to a molecule. I would do no justice to repeat his words, but when he sounded very convincing when I heard him.
I'm always fascinated. Just take time to study the periodic tables. You can see how close some of these elements are, and if compounds can coalesce together with their elements to form different substances, why can't elements change? In fact, they do. I mean, just bombardment with cosmic rays creates neutrons, as does electrical discharges creates neutrons. And so you slap a few neutrons onto something, or you can break it apart from, nitrogen and oxygen, all closely related elements. So I don't understand why more thought's given that. It's locked in at school. It's still taught that elements are inalienable. You can't break them down.
Well, that's literally the definition of the word atom, almost, I think, in the Greek.
Yeah.
It means like distinct particle or something, and elemental clearly does, fundamental, elemental, in that sort of vein. And it's those, that right there is something that, we here like to hinge on a lot, is that recognition of how something innocuous like naming something or basically the meaning of a word, meaning atom, individual, element, type of thing, those type of things comes back to become an unconscious barrier that stops us from, because clearly there has to be movement.
Just labeling something does narrow it down. Yeah.
Well, the possibility in a high electrical environment to, because these are literally charges, moving protons from one nucleus to the other via internal plasmoids and other things in a lightning bolt or the surface of the sun or whatever.
Well, you've just seen that film I put together on the Wallace line, where there's a demarcation between vastly different species. The marsupials on one side and the lion, tigers, elephants on the other. Where I'm theorising that a giant, because it's a geological demarcation as well in Indonesia, and it goes all
Dave,
the way
go
down
look that up.
You're talking about polyploidy, right?
Polyploidy, yeah. Now this is the effect of well, for instance, culture scene. There's chemicals and
it's called the Wallace line,
and other things like extreme pressures, extreme cold can change the DNA under extreme circumstance. DNA adapts to it somehow, whether it's provided by God or its own innate intelligence is a debatable theory and probably quite irrelevant to the argument. But
actually, if I may,
catastrophic circumstance.
I just want to add, you are 100% correct. There are two instances that I know of, right off the top, that are examples of this. There's a lady I know who well, I don't personally know, of course. But she used to do long distance swimming while in cold water, so Arctic swimming. She developed an extra layer of fat along her skin to insulate her, and she developed that over her lifetime while doing this. So this was her environment. She was constantly doing this since a young age, and so she became, immune to the cold. The thing was, her daughter was born with it. Now,
oh, really?
Yes. So that's instant. There's another simple example of, unlike in most situations, when you get cold, your body begins to conserve body heat to your center torso, so to speak, to try to make sure your organs, and it will sacrifice your limbs. And, that's how that goes. Now, however, the Inuit people in northern Canada can work with their bare hands at like -30, because for some reason the blood will still pump through their fingers,
really?
to keep them warm. It's like
So
they don't need gloves, to do, because they never had them. It wasn't something you could do a lot. If you needed fingers, you needed to take them out of your mittens, right, to do something. So you were intricately working on something like that you needed, like, say, making a fish hook and putting it on something to fish with. And this was a matter of life and death, obviously. So you needed that fine detail, and you couldn't wear gloves, and that would take an hour. So you're not going to get frostbite. They did the work, and apparently, that's some sort of trait that seemed to be environmentally driven. That seems to be beyond the idea of natural selection almost.
Yeah. I always been very dubious about natural selection as a former of new species, that's for sure.
Well, there seems to be some truth to it, only because, apparently, the elephants that are being born with no tusks are from a particular group of elephants that were born without tusks, and that's why those are the ones that survive, because the rest of them are getting killed for their tusks. But I don't know. Go ahead.
The thing that always interests me is most of this speciation occurs at extinction boundaries. One is wiped out under catastrophic circumstance, and the survivors have had their DNA changes to adapt to this new environment, whether it's a new electrical environment or whatever. The DNA senses something needs to be done. That's my thoughts on the matter.
You have
still always theories, but you can see the evidence. The extinction boundaries, because above the destruction of those mammals or whatever it happens to be, there's totally new speciation. And
yes.
Speciation is very difficult to explain, but it obviously isn't random, and it's fairly intelligent. Where the direction of the intelligence is godlike, if you like, or whether it's part of the DNA's inbuilt intelligence to sense it out,
or manufactured through environmental or quote unquote epigenetic expression or something. I understand. But you're right. I mean, your Wallace line seems to be a physical demarcation line, which also happens to seem that seems to also be similar to, for example, megafauna just suddenly disappearing, 10,000 years ago. Like why?
Yeah. Well, the interesting thing here is the Wallace line's impregnated on the Ring of Fire, and which runs through Indonesia, Japan, who knows, and goes all the way down to Antarctica and encloses Australia, New Zealand, and Antarctica and parts of Indonesia. But the dramatic change in the species either side of the Wallace line, something to be this boggling, why? How's that happened? Like marsupials are totally different to mammals in so many ways.
Oh yeah, duck-billed platypus. You don't have to tell me Australia's strange. Plus, every single thing apparently is made of poison and will kill you by spitting at you or something. Basically, the only thing I learned about Australia is don't touch any animal. Just don't go near them. Just run away. Just run away and hide. The only thing we have to really worry about is bears and moose, although those are bad enough. So maybe a pack of wolves.
Pretty tough.
But still, this line is physical line as well. Go ahead, Heather.
It's okay, because it is a very physical line, and it's definitely a definitive line in speciation. What's on either side of it, and I'm just wondering if we have any correlation between. First of all, it's important to understand why they're Wallace lines and who Alfred Wallace was, and why his ideas were different than what we've been taught about Darwin's lines or Darwin's ideas. And the other thing is, like, do we notice a correlation or any kind of the types of fossilizations that are happening along these lines? Are they closer to these lines? Are they far away from these lines? Is there any association between these lines and the types of fossilization that we see?
I can't really answer that question. I'd just be guessing, because a lot of these lines are undersea anyway. But you can see different fishes on one side of the line and different fishes on the other. That's how dramatic it is. And as for the fossilization, I would imagine to produce this speciation, there must have been an incredibly dramatic effect occurring, and whether he was even able to fossilize things. I mean, it's totally different. For instance, let's say go to India, where the Sarawak Hills are layers upon layers of different fossils, which are totally different to the ones underneath. And, there's many levels of them going all the way into Burma, or whatever they call it, Miramar now, isn't it, or something, I can't remember. But that's incredible, and that's quite apparent, and vast destructions there. But as to the Wallace line, to be honest, I've been to Indonesia a few times, and I've never even thought about it when I was there. It was just later on, discovering Wallace's writings as against Darwin's, how he thought differently about everything compared to Darwin. Well, for instance, he didn't think natural selection was the reason behind speciation. He thought he was some sort of intelligent thought at work, whatever it was. But in answer to your question, I honestly don't know the answer to that one. Apart from in Antarctica, for instance, there's many different fossils. There's forests there, glauciferous forests, which are heavily turned to rock of some description. And there's dinosaurs down there, and even apparently marsupials along the Antarctic Peninsula. So whether the effects went as far down, but it's certainly there in Antarctica and encompasses that region all the way to Turrbal-Fuga, I believe.
Well, we can't deny, we really can't, that, I mean, literally the name of the Arctic means place of bears, and Antarctic means place of no bears. So we know that these really strange, there is a clear definitions of life at certain points. Now, you bring up something that I never really considered. I considered it over time. I considered for example, that perhaps during some close encounter with a group of planets in a wonderful we'll call Velikovsky array or Talbot-like organization. Those in the catastrophist way, that could explain perhaps maybe the megafauna. Why did things get big just 10,000 years ago, and why did that stop? But I never really considered the possibility that there's a different potential between the North and South poles, and, for example, we all have heard about these stories of dream time from the Aboriginal type of talk in that area. So their skies were lit with aurora, and they were in the south, and they were one of the few land masses in the area because the south has less land, just period. So it makes you wonder if that had something to do, like, for example, the predominant flow of the currents perhaps was having an effect on life. The general, that plate vibrating in a different frequency, because it has to, I mean, literally the electricity must go through the planet and be processed by the electron, there's telluric currents underneath Australia, as in every other continent. I think one of the things here you've got to be careful is, for instance, there's a lot of controversy over when the Aboriginals actually settled, and I believe my work that they obviously came from the Dravidian people from India, and they probably didn't. There's accepted, which I believe is incorrect, that the Aboriginals
came to Australia about 40,000 years ago. I think that's dramatically wrong. I think they've only been here about 3,000 or 4,000 years. But they're quite distinct, of course, from the marsupialization, if you like. You know, they came later together with the dingo. So they came at a different period. So the Aboriginal legends, which aren't that old, or theories, really wouldn't have anything to do with this dramatic speciation change, I wouldn't think anyway.
Oh, I was simply that's one of the few things I can remember, and to be perfectly honest, I feel very bad that is the truth. But besides the few things about Australia, that was one of the things that I remember was a story, was, you know, the dream time, and I pictured this the aurora running across the landscapes and so forth. Now, perhaps maybe those were just events, you know, obviously.
Oh no! Don't get me wrong. I'm sure that there was some dramatic events.
Yeah,
but I don't think this was the speciation events. You know?
Clearly, I was simply. Yeah. You know, I was simply waxing poetic in thoughts of wondering what could possibly have caused this, because really, it's a wonderful conundrum.
Well, I mean, there's many Aboriginal legends which are quite fascinating. You know, not least of which is the diamond mine legends, which where the diamonds were created by the giant barramundi leaping out of the ground at Kununurra and coming back into the ground 200, 300 kilometres away
yes.
Another place, where at both ends there were diamonds. So that's interesting in its own. And, of course, the rainbow serpent.
Perhaps this metamorphosis that we were talking about, this fusion, this, you know.
Well, the other thing is the Aboriginals give that credit for creating the watercourses, the mountains and everything. So something dramatic was going on with the Aboriginals at some time as well. And I think there's been far more dramatic things happening in the Pacific Basin, perhaps 2, 3, 4, 5,000 years ago than happened in the northern region. So in a way, Neil, I can see what you're getting at. You know, I think it's a mistake to think these things were necessarily worldwide. I think they've often been concentrated in certain continental areas in many cases, not just the whole world at once.
The looping idea really makes a lot of sense to me. Obviously, Andy Hall's talk and about these loops, and of course the fact that we see coronal loops on the sun sort of yields the mind to imagine a lower power version than the sun. I mean, perhaps happening on a planet's surface and being induced, because that's what would happen if you can create a current under the ground between point A and point B. Well, to finish the circuit, it will want to go up and above as well, you know. And this could be induced perhaps maybe by something in the ionosphere lowering down or pushing against it. Many different ways that you could envision that something like that would happen. Not the least of which was just planetary involvement, but clearly it would be regionally a regional catastrophe as opposed to worldwide.
Well, but I'm sorry. I just had a question for you about these lines, because the lines is the speciation, the Wallace lines are still in existence. There's still a definitive line for these things that is going on currently. Present day evolution still happening. So, do we notice any kind of electromagnetic differences in these lines that are like in our observance of the Earth's magnetosphere, space weather, regular weather? Do we notice differences that also go along these lines?
Well, look, I'm sure there must be, because wherever you get a volcano or an earthquake, there's a lot of electrical activity goes on at the same time, and so I'm sure you're well aware. So it'd be interesting, though, but it's obviously at a relatively calm period in the history of that particular region, although we see it as things like Krakatoa as quite dramatic. I mean, it's probably small fry compared to what has happened in the past and what happened at the Wallace line. But I'm sure there's electrical connotations as well that are going on. As with all earthquakes and all volcanoes, they're essentially from my understanding at least, certainly talking to Wall at length about this matter, there are electromagnetic changes going on.
If there's something...
I mean, just look at volcanoes and see the amazing electrical discharges. I know, for instance, at Rabaul on New Guinea, there were two cones about 20 kilometres apart shooting thunderbolts at each other, which is
right
to explain. So, and that's fairly recent. That's only, 20 years ago.
That's amazing to think about.
Right. I wish they had better footage of that. I tried digging that up when I read that.
I have comment. Well, I can't even find. I've only got the verbal testimony, which is
right. I tried to look up a picture of it too, and I couldn't find anything. But I had a question too, because I know that you had mentioned in that podcast when you were talking about polyploidy that the DNA string would actually alter according to the frequency that was going on with the change in the electrical potential in the atmosphere. And that kind of I wanted to tie Buddy into this one because that would he actually shows how animals can, and like fish and small avian creatures can actually appear in the harmonics of the Doherty set. And I wanted to see if that would be like a tie-in, if that's actually how that would happen.
Yeah, well, I know, I do know this, the polyploidy invariably occurs in plants anywhere under the influence of chemicals like colchicine, and fishes, it happens all the time. In mammals, it's apparently fairly rare, but can happen under neutron bombardment quite safely, apparently.
Nothing about neutron bombardment sounds safe.
Well, I know they've experimented with many of the electromagnetic spectrum, seeing how damaging they are to when you get mutations, and apparently neutrons are relatively safe, and they maintain these mutations as well. But having said that, I've forgotten where I dug half this stuff out from. That was when your mind's going 1,000 miles.
I didn't help there. I should let you know that was sort of like a rhetorical joke. I wasn't really trying to elicit a response, but it's just like neutron bombardment. No one goes around and goes, yeah, what's happening over here? Neutron bombardment. Yeah, that sounds safe. Yeah, it just doesn't sound safe. But yeah, I know what you mean. I recognize that obviously what you're talking about. But David Brown, you're going to clearly have to figure out how volcanoes work. We'll work on that together.
Well, yeah, I'm working on that one.
I think he actually already has. I mean, if you've seen his last post, it almost looked like there was a volcano in it. It just hasn't been spewing out the magma yet. It just didn't reach its
now he has to make them shoot lightning bolts at each other. See, this is a process.
He can do that. I also I had mentioned to him earlier about the instant fossilization. Is like, why don't you just get your clay mix and then use pond water and then put it under a microscope and see if you could fossilize the microbes, and then just be a matter of scale about size.
So yes, Peter, if you have something that you'd like to try, actually, David Brown's as an experimenter. He has a little setup there.
Really? Well, I have to have a think about that one. That sounds interesting.
Well, I'm sure he wouldn't mind trying to buy a little goldfish and then electrifying it into rock and seeing if that would work. I'm just kidding. But still, I can envision that you could do something on that level. So he has a great little camera on his phone that is like a microscope, and you can see the picture. He can zoom right in and look at you. It looks like you're looking at the surface of Mars being fried.
Right there is where I thought he was making a volcano.
Well, the other thing, you're dealing with high voltage there, but as you mentioned. Neil, there's a lot of this stuff's obviously occurring at much lower voltages. I mean, for instance, one of the Aboriginal legends that always excited me was there was a big one up near a place called Wilcannia, and it killed a lot of Aboriginals, and they fled to the hills, and the country flooded. But one of the hills there turned as if it were to a glutinous sort of matter. It was not volcanically hot and soft. It was the same temperature, but they tread in it, and it was just soft. So I assume that's an electromagnetic effect, and that's one of the things I've been trying to figure out. Well, I was discussing this with Ren Vanderslade last week, about all the mythology. He's doing a big book on that at the moment.
Well, we cannot deny then the nature of, for example, this sort of stonework that seems to be like geopolymer, as people call it. Megalithic stonework that looks like impossible to make, perfectly smooth, wonderful looking stone that is almost organic in nature, like it's been poured, but it's clearly not. So this is something I talked about before. In the past, was there something that in the electrical potential of the Earth that also changes not only life forms, but the properties of the elements themselves, and thus the properties of the I guess molecules that make up all material?
I think something's obviously happening. They knew how to change it. I mean,
this story is fascinating.
It's on Baalbek, which is made of 1,000-ton blocks. They're about 70 foot long, 14 foot wide, 14 foot high. And they carted these from quarries. But the more important point is they're meshed together. And, I mean, I was there at the site and we filmed it all. You cannot put a razor blade between these 1,000-ton blocks that are edged up against each other. And they're also put on other huge blocks mounted about 10 foot above the earth. So
look up trilithon, Dave. Trilithon.
I'm blowed if I know. Well, and one would think it's maybe that electromagnetic one, who knows? But they weren't cut by chisels or saws or things like that. The precision is just incredible. And I guess the same things applies to those huge blocks, all throughout Greece and South America. And, I remember going up to Bogoskoi in Turkey, up in the hills there, and it's exactly the same thing, these crazily cut megalithic stones. So one wonders how on earth they did that.
Well, it's those, like, I was just telling him to look up the trilithon there. It's in Baalbek. It's so big that it's hard to imagine the size of the stone, but it's 2 or 3 stories tall if you're standing on it, like maybe 2 stories, maybe 2.5, and of course it's like 70 feet long or more, and that's the pregnant stone there. That's
well, they've got 2. They've got one there, which I feel.
There's the trilithon.
I'll
you can see.
Up and along. That's not finitely cut, I might add. And there's one across the road that's even bigger that no one actually gets to see much. It's in the.
Yes, I saw that. It's apparently 1,600 tons.
Yeah, when you see them used at Baalbek itself, the building. This is when you realise how amazing.
That's some of them right there.
Was.
The trilithon.
Yeah.
Oh, yeah. No, that's the anyway. Yeah, it's the Baalbek trilithon,
just the base of Baalbek, and they're
just to the right. It just says Project Baalbek Trilithon. Just click on that one. Yeah, that one. There. Those are the ones that see that guy in it? That's the guy, yeah. Those are fit, and there's 3 of them put together along the base of, I guess they called it the Temple of Jupiter, and or Baalbek, I guess. But you can see where the Roman work is on top, and this is clearly megalithic. Like nobody put that there anytime recent, and not during the Roman times for sure. There's no way you couldn't move those today. And this is what I mean. Something must have changed in relation to gravity and apparently the properties of material, stone or otherwise.
Some of the legends about Baalbek are quite intriguing. I mean, they were meant to be built by the genie, which had wings on them. You look at all this mythology of these people with wings on their back, whether you call them angels or genie, I don't know, but you wonder where all this stuff comes from. But that's probably
Well, actually, that
another thing.
I was going to say Julian West could probably answer. He would probably go, "That's just the magnetic field of Jupiter, man. Let's not get weird."
Well, why don't you think that Romans could not build it? I mean, the architecture actually looks pretty regular for like Hellenistic / Roman.
The Roman architecture
is on top there.
Some of those columns are. When I think we measured them, they're about 90 foot high. They're huge. They're probably the biggest columns. We're assuming they're Roman, but they might have been a little bit earlier. But a number of people have rebuilt over, including the Moors and various things. But earthquakes have kept on knocking them down. So I think what you've got in Baalbek is the original builders, which hasn't moved an inch even under the earthquakes, and those that built on top of them, and they were successively knocked over by various earthquakes, 1200 AD, etc. There's the whole chain of them. But there were the Romans, there was probably maybe even the Greeks, who knows, but a number of contributors to Baalbek. And they all had theirs. I mean, it was a fort, I think, in around about 1700, 1800 with the Turks when they overrun the area.
But to answer your question, Eugene, completely, they're just too big to move, the stones. They're simply physically too large to move.
They weigh 1,000 tons. They weigh 1,000 tons, and they say they couldn't move them with a mobile crane. They couldn't move them even today from the quarry, which is a kilometre away. So they're pretty big stones, all right. But that's really, I guess, a subject for another session.
No, of course, but it's just wonderful we're talking about it. It's no one could deny the attractiveness. It's all ties together. We're basically beginning to accept the fact that the story that we've been told about the history of the world is based on a few assumptions that are quite clearly or quite possibly wrong, and that paints a whole different picture of our past.
Well, it does. Yes, it does. I mean, some of this stuff's inexplicable and is only hinted at in place. Some of the biblical stories and the historians, Thucydides or wherever you tend to go, to find out some of your ancient history are quite startling. How do you explain things like the heroes in Greek mythology? Was it just a load of rubbish and make up, or was it seriously a fact?
They took it rather seriously, it seems.
Oh well, there was a lot to it, that's for sure.
But on to your specialty, clearly is the fossilization, and I'm glad that you brought up those crabs, the ones that were encased in stone. It reminds me of those stories of the frog that it comes out of a stone, like alive. In the Reader's Digest Mysteries of the Unexplained book or something, like those coffee table books and that you got in the 1970s and 80s, type of thing. And yeah, I've read in those type of things, where they said, yes, and he swears, and these men testified that this frog comes out of the stone. But it's interesting that there's a halo around the crab itself. And to me, just as what I'm looking at, I see like perhaps maybe the shell of the creature, which would have been a different material with different resistances, would have set up a double layer as this creature was being, basically turned to stone. And it would give you a positive nucleus and an outside. Sorry. That's what I mean. So you'd have a change in, and this seems to happen with certain creatures, like with shells, or maybe amphibians, because they happen to be completely covered in a slime or wet at the time.
I saw an image that you guys posted that you showed earlier, and it looked like I want to say a deer, but you could still see the shape of the body where the skin and the meat was. And looking at this crab here, and doing some of the electrical work I've been doing with clay, to me it's always looking for the water and extracting the water or anything that is wet. And when I look at when I look at these crabs, especially with that halo around it, it to me it kind of seems like the reverse of how they say fossils are created, by fossils having all these minerals go through the rock and absorbing into bones and things to fossilize it. But looking at it from this perspective, if there's electricity going through the ground and sucking up that water for that discharge, it almost seems like it sucked the water out so much to then it started extracting the mineral from the crab itself, and that's what the coloration of the halo is. That's just a thought.
Or the fact that they get opalized.
Yeah.
Yeah.
Well, and that seems to be what we were talking about before, is the how if you get an internal shell. I mean, this would have been encased in electric rock falling from the sky. That was probably falling at a rate of like inches per second, and this thing is just getting buried in this stuff. But this stuff is also a plasma because it's still conducting as it's being welded to the surface. And this poor creature is just the result of being welded, frozen in time, done. And then, of course...
What are you saying that, Neil? You say falling from the sky. What was falling from the sky again?
Well, in my opinion, when I see something like that, I see, and this in many fossil cases, material is falling from the sky and burying these creatures in what would be considered, if I was looking at it from a different point of view, it would be like welding. It would be like you're taking electric sputters from a arc tip and you're welding it to another surface. Okay, and you're actually physically adding material. Well, this is just little tiny atoms of material that's being pulled off of this thing, but it forms a particular metal in the weld because it all comes together in the weld. Now, the same thing would happen across a planet's surface. Then a creature like this poor crab or snails or whatever, is just sitting there, and it's getting buried in material very, very quickly, like inches per second, as this material is welded to the surface. Now, and it's electrically welded, so there is electricity coursing down through this material. And the result is, of course, that this thing is totally fried while also having itself crystallized. And because it had a bunch of moisture, as Dave was pointing out, and a shell around it, it probably had a different potential, like you would imagine a planet might, in that environment for a short period of time. So it just basically became like the nucleus of a discharge, but it's clearly dead, But that kind of idea.
One of the things I find interesting is along coastlines. For instance, the Jurassic coast in England, where they have all these ammonites embedded just on the surface and spreading for 2, 3, 4 miles in incredibly large numbers, and varying from 10 foot across down to about 2 foot. And to me, it looks like an electrical discharge has gone right along the coastline, because there's also layering above the sandy, pebbly beach of basalt and soft coal-like material. And so that's one. The second is when you come along, for instance, to Australia, Victoria, there's coastlines where all the plants are being turned to silica. And along particularly large areas along the coastline, and surrounding it is the old growth, the new growth, exactly mimicking the fossilized or petrified old wood. So I find that, and they're still embedded in the sand, So I tend to think that a lot of this stuff's happening running along coastlines.
You're absolutely right. In fact,
coming from above, you know what I mean?
We have people like Buddy to thank for that one. Buddy was spraying using his magic electrical powers, his transformer there, on a piece of wood, and he uses a solution with water and other variants of salts, I assume, or other material, and he sprays that onto the wood. Now, if he gets it too wet, it doesn't conduct as well, and if it gets too dry, it doesn't conduct as well. But right along that boundary, and of course that makes also sense because there would be the telluric currents would definitely change at any water level at any time you meet a body of water. So this is where I assume, and I shouldn't assume directly, but I have this strange feeling that there is a connection between the like the Ring of Fire and the fact that the Pacific is so large. You know, everything is volcanic in that area because everything is conducting such a massive amount of. I mean, if you look at the surface area of the ocean and realize that the electricity is not going to go through that water, it's going to go to the sides. It's going to go to the volcanoes near the edge to try to get in into the inner core where it wants to go, so it can be processed. That idea.
That makes me think of ambient electrical currents as telluric currents. Like when lightning hits certain spots in the ground, it doesn't just stop and dissipate. I mean, I'm sure there's a radius of dissipation, but instead it goes out and becomes like an ambient electrical structure, like maybe longitudinal waves across the surface at a low vibration, creating a current that we can't even detect, and many currents that we can't detect.
Actually, it's argued that Go ahead, Peter.
No, so that's interesting.
Well, there's a
one. The other thing, I mean, in a bit of support of this, if you study thunder egg formation, they're in a particular layer that might be, let's say, 10, 15 foot deep, and they progress from top to bottom down, along this horizontal layer from roughly single thunder eggs to multiple thunder eggs coalesce together in a little polyp.
So the thunder eggs and the balls, because this is something that I've been wanting to ask is like the Moki marbles or the Martian blueberries that's stereonthymated when we're talking about the little spheres that are created by plasma discharge, like that are kind of thrown off.
I think they're all made the same way, yes.
Hail. Right, like hail. So if these types of occurrences are happening along a water line and therefore maybe tornadoes are occurring and hail is happening in the environment, then that's throwing moisture balls out as well to attract these things. I'm just seeing a lot of little spheres being created at a certain level in all of these processes.
Yeah, well, I'm sure that's what's happening. I'm sure that's what's happening with the thunder eggs, and really these things with the crabs in are another form of thunder egg anyway.
And planets and stars.
Well, yeah, exactly. Where's the beginning and end? Yeah.
Well, this is where I'm. But
it's seeking the form of least surface tension.
Well, actually,
and that's a sphere.
It's not necessarily surface tension. There's a pinch effect that will crush things into spheres. Number one, but if there's any sort of thing that has for example, a positive core about it, it will basically anything higher than a certain point will be ripped off, and it basically becomes a piece of dust. And this is basically, we see this in Dave Brown's experiments directly because he zoomed right in, and you see the electricity coursing through a little clay cube. And then suddenly a piece gets a little bit dry. You can see it drying out. It's turning to from a darker brown chocolatey clay to a not so dark chocolatey clay. And anyway, more like the peanut butter. Anyway, so and then suddenly it gets pulled off, and immediately poof, it's dust. Well, this is what happens in electrical discharges because it's atomizing that material, and that happens if that happens to things on the Earth while you're there. certain things can survive it. Certain types of materials are going to be more conductive. They will not be ripped apart as easy. But once you have a breakdown through a piece of material, it's quite easy to basically rip it into atoms. And then that stuff will be laid down again and welded to the surface in different formations. And this is what I think is basically what happens during these events, if experiment holds true. So
wouldn't the vortex the shape of the vortex happening force the matter into a sphere?
If there's a pinch, because what causes it is it seems like
I'm seeing like a ball tumbling, like a stone tumbling. You put it in a tumbler, and the more that it's spun and turned around, if it's done evenly, it winds up forming a ball. You know what I mean?
And then these plasmoid ideas too.
Plasmoid and pinches are very similar.
Right.
Just
saying, like, the motion of the current is what's creating the matter to become a sphere. That's what I'm trying to digest here. That's what I'm hearing. That's what it looks like. It's this.
You can also
shape.
One of the things you can see is the fact that sometimes some of these things look like they're crushed together, like this right here, and other ones of them, you can see on the inside that you can see clear layers, and that's usually a symbol of Markland convection type of ideas, like giving you the distinct layers basically by element. And this is what seems to be happening. They're basically electrically sorted, and that's a property that usually
You're
happens.
kind of talking about the stone.
Yeah,
what?
like
Are you
right
kind of
there.
talking about the stone spheres that are like broken?
Yeah,
that one right there. See that has a crystal in the inside, but it's been sorted from the material. Like there's electricity coursing through this thing. It's not able to crush it completely. It's trying very hard, and it gets a harder outer shell as it cooks a little bit, and it's able to basically resist this atomization process, and is rained down with the other material and then we find it later, and this is what it looks like when we pull it out of the ground.
Right.
That's my interpretation. I could be wrong, of course, but if I was a betting man, it's sort of like welding slag. Like if you're, because welding slag turns little tiny spheres.
I've done a lot of welding, and I've done a lot of forging, and I know what the inside of a clank ball looks like, but I also know that when you make that contact with the material, that whatever slag comes off of it, at that process, there tends to be little bitty spheres. And I know that CJ Ransom in the lab, using with plasma discharge, made little spheres, and so that's what I'm wondering, if it seems instantaneous to us, maybe, but maybe it isn't. But the direction.
Well, there must be a length of time, but yes, short-lived, certainly. In my interpretation,
there's different ones that aren't spheres, but I'm speaking specifically of that shape at that time, because that's what seems to be the eggs, the crabs, hail, the eggs, the mookie balls, and in the process of forge welding that happens. So
yeah, literally like welding slag. You're right. It is in a kind of way, yeah. And obviously, just this rate alone, just that picture tells me that you should have been thinking about this, because if you can find an axis on something, then it was made a certain way. There's principles here. It has a polar, it has a ring and a pole. Now, if you get really good, like planets, it is almost 100% a sphere, but not always. Sometimes there's little leftovers, like a ridge or something. And the Earth is no exception to that rule. It looks like that right there, crushed together.
I don't really agree with this idea that there's something coming from above. This powder's coming together and getting welded together. When you look at water, and you look at the animal, the crab, they both have a lot of water in them. And then the water's got a lot of carbon in the form of amoeba and other little critters. I think it's an instantaneous transmutation of water and carbon into silicon. There's no additional material being added. If you look at Peter Mungo Jupp's one of his films, he talks about how the mastodons were hard to discern from the rock they're embedded in. Like the whole thing turned to rock instantaneously.
Well, yes, but what happened on the outside? Like, where does all that rock come from? Is what I meant.
It came from the water in the silicon. It was instantaneously transmuted into the water and silicon combined together to make water and carbon add together to make silicon.
But guys, do you know? Did anybody measure the masses? I mean, is there a mass increase during this fossilization?
I assume it would have to be, since stone weighs more. It also doesn't explain why sometimes we find bones and sometimes we find the whole body. That's also something that's interesting. Like it's like.
I think you're doing that two different things here.
Yeah. Maybe
when you're getting a very destructive thing like perhaps massive tidal waves moving across continents, mixing up trees, mammoths, as happens in Siberia, as happens in Alaska, probably Greenland for all we know, you're getting a mix of things, and then they're preserved by the ice and they're mixed with sand. Maybe sand's part of the process that's destroying the geography at the time. I think that's a different process. That's more fossilization than petrification. With petrification, I believe you're getting transmutation of water to rock. You just look at the atomic table, and you can see the relation between H2O and silicon. When you introduce neutrons into the element, say you're getting bombarded by neutrons, which electrical discharges produce, that would explain any increase in mass, surely, or change in mass.
Well, I have a counter, but Eugene wanted to speak.
Well, I just wanted to ask whether there would be enough water in this organism to create as much rock as would be needed, if there is a significant mass increase.
Well, if you go to South Dakota to the mammoth site there, the mammoth itself is indistinguishable from the calcium type earth it's embedded in. You can't tell one from the other, except the boundaries are marked by some sort of slight change, perhaps due to less water, more carbon, or more whatever in the animal than the surround. But it's obviously a water basin, and they were killed instantaneously, otherwise they would have deteriorated. So something's happened instantaneously, not only to the animal, but to the medium. And as I say, they're nearly indistinguishable when you see them in situ on the site and in their laboratories there. They take CTs of them and everything. And if memory serves me right, they're not that much different. The collagen's all gone out of them. Whatever's happened to it, I don't know.
I gotta give you credit for that. That looks very convincing. However, there are two things that I'm only saying this because
one more thing.
Oh, do it.
The site, which is perhaps the most compelling thing, is it's thousands of layers of this calcium. But I would argue that they're probably electrical form layers, much as if you do isoelectric focusing or electrophoresis, you get the molecules separated by their isoelectric point. So I think something like that's gone on there. These micro layers, they're not just dump layers, because the layers go right through the mammoths themselves.
Well, I was going to say, weren't you not the person who told me we were? I think we were. I don't know where we were. I just don't know where we were. Okay. But we were walking, and we stopped for a moment.
When I carried you when you ran out of breath.
Thank God you were there, my hero. But What you told me was that there was a fossil of bone, but you could see clearly the layers going up the body, right through the bone. It didn't matter what the bone was, but the fossil and what it was embedded in had these stratification layers that were clearly like pulsed electricity or something, like the remainder of some sort of giant harmonic disturbance or something.
Yeah, well, I don't know what caused the layers. I mean, I jumped to the electrical theory because having worked in laboratories with isoelectric focusing, and immediately think, well, there's some sort of separation going on here, all these layers. But I'm open to any other suggestions. It clearly wasn't sediment over years, though. Like one layer after
that
another.
We can all agree on.
That
right there is something we both agree on. But and in fact, I'm very open to the idea that there are multiple processes happening, or that can happen depending on whether or not it's hitting water, whether or not it's because I have to admit that debris did rain down upon the planet. It's clear that it's happened. We find that it has mountains are welded or seem to be welded together. So we seem to have that. However, I also know that's different when it hits water versus not hitting water. And I'm willing to open to instant electrical transmutation, totally open to the idea. In fact, 100%. However, I have noted that in certain cases, when we were on our geology tours there, I was with Eugene, and we went to a particular place that you could see the layers as they were, in my interpretation, falling, and how they switched, but how you could see spheres of the layer coming up embedded in the rock below, as if you can see nodules basically in a sandstone as a calcite is coming up, so you can see that sort of layering that sort of has a time lapse factor. And there also seems to be circumstances where we see footprints in layers, like as Robert found one time. Just looks like some sort of brontosaurus was just like, I'm getting the heck out of here. Like there's ash falling from the sky. I need a place to be. Okay, come with me, brontosaur children, or whatever. And you can see that they're embedded in this one layer. And but it's clear that the layer above it was the hard part that fell into this footprint. What was welding to this layer? That type of thing. Just little things like that seem to say that there seems to also be a circumstance where deposition is burying things as well. But obviously, we have evidence of something else, something perhaps maybe more powerful, just like note your rock, like boom type of effects.
Well, one of the things I do find fascinating, I think I was in Bali a couple of years ago, and there was these, they were dry rivers, but they were lined, the whole of the river and the beach line were lined with these huge boulders, I guess about 2 foot across, fairly spherical, and they ran down from the mountains, and it wasn't a lava flow because these were separate boulders, but then it went along the whole beach, this black basalt, really solid, and I'm thinking to myself, I wonder if that's an electrical discharge, creating this stuff, running down the dry riverbed and then along the beach as well. So I suppose the real question is we need a lot more evidence to see how these things are created. I mean, it's a bit hard trying to emulate some massive discharge like that, or assume it's a massive discharge anyway.
It's also hard when there is a, I guess you could say, a scientific orthodoxy against allowing that interpretation to see the light of day, because they think that it's going to turn into a creationism fight.
Neil, these things aren't going to change overnight.
Oh, God, no.
generation to make a change. I'm sure the electric universe is going to have its day, and then who knows, something else might come along to shatter that theory. You know,
I think
it always pays to be extremely cynical about everything and don't become an ideologue.
That's a good.
I think this is where David is pointing in the right direction. It's like you scale it down and then you try to simulate it and see how close you can come. What's the action, and then go back, try to get a full chain of comparison, and then publish as much as possible.
Yeah, well, I'm all for that sort of approach.
Yeah, I'm trying to take a kind of a Velikovskian approach with, the world, maybe the magnetic poles flipping, and there definitely being some sort of floodwaters involved, as well as at the same time, earthquakes and volcanoes. So not only is there a vibrational aspect from just what's going on with the planet, but also I would imagine some sort of dust falling from the sky, like Neil said, in addition to floodwaters, in addition to the continents moving. My personal theory, it being expanded from this big discharge event. But when I look at things like Google Earth, you can go over there and look at the Asian area, where the Middle East meets Asia, and you can see where these pinching points come together. And the geology is very different on each side of these so-called butterfly wings, I think, as Michael Steinbacher called it. But it looks like there's two very different potentials, or two very different systems of storms, if you will, or ionic winds that are converging, kind of like just some crazy massive.
Just look at that right there.
Yeah.
I mean, that mountain range alone, the Himalayas or whatever that is I'm looking at, plus that desert, is just, looking at it through your experiments and just seeing how you could see the Lichtenberg patterns right there, and then you could see this long sweeping motions and the apparent positive and negative aspects of the whole mountain range. This is what I mean by some things must be buried, but clearly, if things are happening in water, especially at the edges where a lot of these creatures, maybe there is something exactly as you're describing, with instant transmutation of the water itself into stone. There's so many stories about turning things to stone instantly that we shouldn't just say that that's something completely, ridiculous.
I can even see it as if there is floodwaters going on at the same time as they're receding and it's drying up, that you're going to have multiple different discharges happening. Peter was mentioning the layers on the coastline outside of Victoria. I think it was the Ammonites or whatnot, where there was different layering down below and up above. So I could also imagine as the sea level was dropping, there could be multiple events taking place over time, and whether that's a long amount of time.
There's lots of interpretations too. I mean, I've heard water being held up by Saturn and the Saturn conjunction, and of course when that ended, the water rebalanced and boom, everything's screwed. But I've also saw the other ones with the Ice Age ones, so I'm on the fence with me, because I have to recognize my limitations. I had to keep an open mind.
One other aspect I'm thinking about a lot of nowadays is reading about, I forgot the guy's name, his deep, hot biosphere theories, where they dug holes down 20 kilometers in Russia and Sweden, I think it is, and they're finding not only bacteria at incredibly deep depths, but him pointing out the fact that he's convinced there's water down to great depths and methane gases, CO2 down to deep depths, and oil, and that they're non-biogenic, they're naturally occurring substances that fossils are buried in rather than created by fossils. And I think there's a lot of...
I think there's some merit to that idea.
Yeah. A lot of the old mythologies talk about the waters coming from beneath the earth and coming up and flooding as well. So I think we tend to neglect that aspect of possibility that I'm not saying is true, but there's a lot of mythology that backs that up. Water's coming from the depths.
Actually, there's a lot of... I just recently saw that you bring a very good point. Let me tell you something that I just recently saw and I couldn't really explain. Was this? There's a hill that's called not Avery Hill, but Salisbury Hill or something in England, and they excavated into it and they saw multiple different layers building up over time, and they thought that human beings did this. Because they found at certain layers, they found bones and stuff, which could have just been people died when it was at that level. But apparently these things happen where water comes up through the ground and brings silt and everything else up with it. And different materials get pushed up through this hole, and it layers different types of material until it's actually quite a large mound. In fact, this one happened to be like 50 or 70 feet high or something. It was quite large. So,
Neil, I think that's Silbury Hill. You're talking about Silbury Hill.
Thank you. I was butchering it. I apologize. No.
Yeah.
But I saw this thing on it, which someone said, no, look, it's actually connected to the water table. This is a natural phenomenon. Not made by humans at all, although humans must have hung around with it because we found their bones in it, so this couldn't be any more than, 20,000 years or so old. But this is giving you the idea that water can be pushed up from underground, and I can envision if we're in a different electrical environment that could easily happen. I mean, I couldn't.
Well, no, it did happen in the Japan earthquake in 2011.
Did it? When
it was 9-pointer, there was water coming up out of the park. Like there's videos of the ground water.
Well, that was a tsunami coming up through pipes.
No. It wasn't the tsunami. It was a guy walking through the park while the earthquake was happening, and water just started coming up from under the ground, like in the lawn. By trees in the sidewalk, and it was like the whole ground was liquid and water was
I would apologize profusely because clearly I would pee myself and add to that water because oh my god, if that has happening around me.
I was talking about that earlier.
About what?
Oh, it was a peeing joke. Sorry.
Oh.
I have to throw something in.
I thought it was too cold for that sort of thing in the US.
Not about you. It was actually about someone else.
So, but still, clearly there's some potential there, and wondering. I mean, there's this mental image that magma, because of a magma chamber, is actually magma, but we know it's not. We know it's not actually connected to whatever the heck magma is. We never really hit magma before. We know it's lava. But what causes lava, besides their belief in that the inside of the earth is, really, really hot and has been for a perpetually long time,
Well, there's no real proof of that. Let's face it, as I say, the deepest hole dug is, I think, about 20 kilometres, and that's about where our knowledge ends.
Yeah.
We know it gets hotter, but no one really knows. I mean, it's still all theoretical that the centre of the Earth's a magnetic iron ball, and that's only because we're trying to explain gravity. Wall happens to seem to think it's hollow. I don't, but I think it's probably more water and gas and oil than anything else. Who knows? We really don't know. Comets certainly are full of hydrocarbons and carbohydrates. In other words, oil and things like that, and sugars, as well as hydrocarbons. So, what on earth's in the middle of the earth, so to speak, as well? I think it's one of the fascinating areas that no one really, they take for granted all this core theory, and no one's really, no one's dug deeper than 20 kilometres into thousands of kilometres of depth.